All right, so our second assignment for week 3 is going to be dealing with electrostatic force. So this is a new force that we are going to be taking a look at. So as you have seen from static electricity, when you have opposite charges of things, those two objects will attract. If you have like charges, they are going to repel. So for example, when you watch the video with the plastic comb and the paper was attracted to the plastic comb. If you were remembering back to what we did in class, you could see that the water itself was attracted to the friction tool. And what we also were able to watch is that one of the demos we did before we left on this quarantine break was we did the balloons and the plastic bags, and the plastic bag was repelled. So this is a type of force that is called the electrostatic force. In last week, you all watched a video that was there to introduce it to you. So today, I want to have you go through a simulator that helps you introduce what the electrostatic force is. So here we have charged particles. We have a positively charged particle, a negatively charged particle, and then we have a sensor. What's really cool about this is you can really place these all over the place. So you can place one here, you can place one over here, and it will show you the direction of the force. The brighter colored white arrows indicate a stronger force, and they also indicate a direction. And what's really cool is you can even stack particles on top of each other. So what I want you to do is I kind of want you to play around with this for a little bit. You can have negative charge particles over here. You can move them really in any direction you would like. You can place as many charged particles as you want on here. But then what I'm going to have you do is I'm going to have you use this voltmeter. The voltmeter really is going to measure what is, in other words, known as volts. And volts are how we measure the amount of electricity, or in other words, the electrostatic force. So you can place this voltmeter anywhere you want, and the goal is to find out the relationship between positive and negative charged particles, but also how strong the force is. Meaning, where is the force the strongest? Where is the force the weakest? Because you will find that it is in any way similar to forces we have studied earlier. Now, this here is a really good tool is because it can be used as a measuring device. So you can measure from the center of the particle, and you can measure outwards and basically give yourself a distance. So the first worksheet that we're going to work on is going to have you go through a couple different scenarios, but it's really here for you to start looking at what electrostatic force is and what is the relationship between the charged particles. You know that positive and negative particles will attract one another. You know positive and positive will repel, and you know negative and negative will repel. The end goal, though, is trying to figure out what is the relationship between those particles. What does the force look like the closer or farther away you are between two positives, two negatives, a negative and a positive. So that's going to be our goal today. So I want you to use the tape measure, and I want you to use the voltmeter as tools in a way to help you. Now, you can use a grid if that makes things easier for you. You don't necessarily need to. For me, I've liked using it with the directional field only and just looking at the electric field itself. You can look at the directions only, but it gets pretty busy. So for me, this one makes a lot more sense. Don't worry about voltages themselves. You can turn that on and off. It just sort of gives you a little bit of a highlight as to what particle you are working with. So today what you'll be doing is you're going to be working through, let me pull this up, this worksheet here. Now this worksheet here has the actual link in the description as to where to go. But my goal for you is either to download the document itself and write your answers directly into Word. You're currently hearing Harper playing with her toys. She sits next to the laptop as I'm recording this. But your goal is it's going to have you go through two different main scenarios where eventually you're going to have to come up with a trial. And you're going to need to create and measure distance. That's where you're going to use the tape measure. The voltmeter here is this blue device here. And your goal is to put single positive charge on the screen. And our goal is to sort of look at the measuring and look at measuring about with it. Then you're going to stack two positive charges one on top of one another. And then also in last night you're going to draw a positive negative charge interacting. So my goal with this essentially is to get you to view what the electrostatic force is, because we've seen it, but we haven't actually measured it. And this here gives us a good description and a good way to visualize what the force is actually doing. Now imagine this force though. This force is happening all over an object if it becomes charged. If one side of that object becomes charged, this electrostatic force is happening over that entire object. So I think this is going to be a good activity to help introduce what electrostatic force is, but it also does a great job of giving you a way to visualize it, because we often only see the two objects interacting. We don't actually see the force that's happening between the two objects. So give this a look today, over these next couple days. But my goal for you is to eventually fill out this worksheet here, and then eventually I'll be making a video that shows what the correct answers are for this, and really what more about the electrostatic force there is and how much it actually has in common. If you want, I would even recommend going back into Schoology. And if you look, if we go back here to materials and we go back to online learning week 2, for each one of our classes, you were tasked with this assignment here. And after watching the video, your classmates looked at what the big idea they stuck out from. So if we look at Alexa's, one idea that stuck out to me was the conductor is a substance that easily travels and can transfer electric charge, while insulator is a substance that doesn't. If we look down here at Karan's, the idea that stuck out to me was the electric dipole. The diagram on the field reminded me that the magnetic field diagram. So you're going to be looking at a field diagram with this simulator, and it's going to be very similar to the magnetic field diagram that you see with a magnet with the north and south pole. So if I were you, maybe take a look at what some of your classmates actually wrote. For each class, they have their own discussion board. So I would really encourage you to take a look at that. Maybe that might help jog your memory. If you haven't watched the video, watch the video first. It's in the week 2 section of our online learning. But this is all what basically what stuck out to your classmates after watching the video. So we look down here. One thing that stuck out to me was the fact the electrical force is stronger than gravitational force by so much, which is even crazier because we often think of gravity as something that's so strong, but electrical force is actually stronger. And then electrical forces are much stronger than gravitational forces. Same thing that Nolan said. And then so each class, like I said, has their own discussion board. So please check this out before you go ahead and play around with the simulator. Good luck. Remember, message me if you have questions. And by Wednesday, you will be seeing a video that explains more about electrostatic forces, so you can get some of your ideas confirmed, or maybe see if you can change some of your thinking should you need to. Thanks.